Here's the answer for day 3, problem 1. 3 times a number equals 1/4 another number, and the sum of 4 times the first and 12 is equal to 3 times the second. What are the numbers? We're told to solve this problem using this technique, to define variables to represent these two numbers and to write a system to model it. For the first number, let's use the variable x. For the second number, let's use the variable y. This is what it's meant to define the variables, to say what x and y are representing, the first number and the second number. Now we're told to write a system. That's done by rereading the clues and creating equations that use our letters x and y. So let's read the first sentence. 3 times one number, that's 3x, equals 1/4 another number, that's 1/4 y. This algebra expression fits these words. Now right underneath that, let's create another equation using the next sentence in the paragraph. The sum, that means to add, of 4 times the first number and 12. So 4 times the first number and 12. Here's our sum. It says is equal to 3 times the second number. That's the expression 3y. So this algebra expression fits that second clue in the paragraph. We're told we do not have to solve the system. So here is the answer to problem 1. Day 3, problem 2. Here's an inequality. Does its graph have a solid or a dashed boundary line? To decide that, you look at that inequality symbol and see if it says or equal to. It does not have that, so it is a dashed boundary line. Does the graph have points above or below the boundary line? To decide this, we have to know if we have a less than or greater than arrow. But it's really important that you don't decide this until after you've changed to slope-intercept form. Because if along the way you ever divide by a negative number, the arrow will switch. So let's take our original expression and convert it to slope-intercept form. Subtract x from both sides. We have 2y is less than negative x plus 6. Now divide by 2. We have y is less than negative 1 over 2x plus 6 over 2, which is really just a 3. We did not divide by a negative, so our arrow did stay the same direction. Now we can decide whether we want to shade above or below our boundary line. This is a is less than arrow, so all our answers are under the boundary line.